Hey y'all, we're here to talk about inferences about means. And so we're going to start with the conditions for this particular problem. Hopefully, you read the problem. And so remember, the four conditions that we are checking are independence, randomization, the 10% condition, and nearly normal. With the nearly normal condition, we want to make sure that the number of data points that we have is at least 30. And in the event that we have fewer than 30 items that or data points that we've collected, we will then need to look at the distribution for the sample and we'll need to examine if it is unimodal, if it is approximately symmetric, meaning there is no extreme skewness. We also want to make sure we don't have any extreme outliers. And if those conditions are met within the nearly normal condition, that means we can move forward with doing our test or interval as we see fit. And so it's important to make sure you check that information every single time. And so that's what we're going to practice in this particular problem. So again, just going through the conditions here, and then we'll keep going. All right, so all the conditions are met, and now we're going to create our 95% confidence interval. And so we're going to start by doing the mechanics by hand. Remember that the n value is 840, therefore our degrees of freedom are 839. So this will help us find the critical value for degrees of freedom of 839. So I'm going to go to the calculator and I'm going to do T inverse or inverse T. Doing the inverse of the T model will help me get the critical value that's associated with 839 degrees of freedom. The area is, remember, we do 1 minus the confidence interval and then divide by 2. That's how we got 0.025, okay? And then we need to get our standard error for our information, and that's how we get the 2.0702, okay? And so we are working these out by hand, and soon enough, we'll have our confidence interval. So now it's time for the conclusion. And so we want to say, I am 95% confident that the true population mean of test scores is between approximately 267.937 points and 276.063 points. Okay. And then sometimes they'll have a question that'll say, what can you say about all 95% confidence intervals, or how can you interpret all 95% confidence intervals? And so that's when we would want to say 95% of all 95% confidence intervals contain the true population mean test scores. And as always, if you have any questions, be sure to write them down in your notes so we can discuss them later. All right, so now for this portion of the video, I'm just going to walk you through how to use technology on the TI Inspire as well as the TI 84 to create your confidence interval for this particular problem. So the second part of this question wants to know if a young American scores 275, is it an indication that they cannot balance their checkbook? And so we want to use the confidence interval to make that conclusion, and we conclude no. And the reason for that is because 275 is within the confidence interval. So that tells me that that score is possible. It's plausible to score that. Therefore, it would indicate that the young American actually does know how to balance their checkbook. So that's why we would say no. All right, so we got most of the conditions out of the way. Next, we are about to look at the nearly normal condition. And hopefully, you can tell by the number of data points that we have, it is going to be less than 30. And so, the next part of this video is me walking you through how to make sure you can actually proceed with the T interval by checking all of the conditions and their criteria for the nearly normal condition. So I used the TI-84 for this particular problem just because it was quicker and easier for me to type in the information. You're more than welcome to use the Inspire, and actually you'll see in other examples I do use the Inspire just to demonstrate how to check the nearly normal condition for those particular problems as well. So either calculator will suffice. But again, I just used the 84 because it was quicker to type in the information and go. So once you create your box plot for your information, you then have to make sure you state that since the sample distribution of, and so in this particular case, it was speeds of the cars, since it is unimodal, approximately symmetric, has no extreme outliers, the sampling distribution of means for the speeds of cars, you can go ahead and say that it's nearly normal. And so that will allow us to proceed with doing our one sample T interval. So on the 84, you have to press stat and arrow over to test to find the T interval. It's actually number 8. And you want to make sure you use data because we had data points listed in our table. And don't forget to change your confidence interval to 90 because it was a 90% confidence interval. So 0.90. And then we do a direct copy from the calculator, and then we proceed to the conclusion. All right, so the second part of example 2 asks us for evidence. And so anytime they're asking us for evidence, we automatically know that we need to do a hypothesis test. And so what we are testing, the alternate that we're testing is that the true population mean of speeds of cars is greater than 30 miles per hour. And so remember, we want to write out the null hypothesis and the alternate hypothesis using symbols and in words, and then follow up with doing our conditions. Now, what's great about this problem is we already did the conditions previously and it's a continuation. So we can simply state, since all conditions have been met, we can do a one sample t-test. So again, on the 84, the test, you have to press stat test, and then the t-test is number 2. And again, we had data points, so we use the data to help us create or perform rather the one sample t-test, and we do a direct copy of the information from the calculator. All right, here comes the 4-part conclusion for our one sample t-test. All right, so part 1, using a one sample t-test, my p-value of 0.036 is less than my alpha level of 0.10. When the p is low, reject the hoe. So part 2, I reject the null hypothesis. Okay, so part 3 is related to your alternate. So if you reject the hoe, you have evidence of the ha. So I have evidence that the true population mean of speeds of cars is greater than 30 miles per hour. Part 4 is based on the question that they're asking. So in this case, we have evidence, okay? So we have evidence based on the data, okay, that the actual speeds are higher. And if you have any questions, make sure you write them down in your notes.